Okay, so part 2, the expansion. Let's rewrite the whole expression. So we had from last time g times the mass of the sun times the mass of the satellite over the orbital radius of the Earth minus d squared. Minus g times the mass of the Earth times the mass of the satellite over d squared. That's equal to g times the mass of the sun times the mass of the satellite times the orbital radius of the Earth minus d over the orbital radius of the Earth cubed. So now one thing we can do immediately is each term has a g and the mass of the satellite. Divide each term by g and the mass of the satellite. The other thing we're going to do is try to figure out which term we can apply the binomial expansion to. So, what's our assumption? Our assumption is that the distance between the Earth and the satellite is much, much less than the orbital radius of the Earth. So what we'll do is we'll factor out wherever the orbital radius of the Earth appears, let's factor that out. So here in the denominator, we're going to factor out the orbital radius of the Earth. And when we do, we're factoring out of a squared term, so it's squared, times 1 minus d over the orbital radius of the Earth. That whole term is squared, minus the mass of the Earth divided by d squared, and that's equal to the mass of the sun times the orbital radius of the Earth times 1 minus d over the orbital radius of the Earth, and that's over the orbital radius of the Earth cubed. So we get one of those to cancel. Okay. So now, if I rewrite this just slightly, I'm going to get something that looks like the mass of the sun over the orbital radius of the Earth squared. And in the numerator, I'm going to rewrite this term so it'll be easier to see the expansion. In the numerator, if you move this into the numerator, it's 1 minus d over r sub e to the negative 2 power. And then we'll just write everything out from before. Okay. So, what does the expansion say? Binomial expansion says if you have something that looks like 1 plus or minus x to the n, assuming that whatever is x is much, much less than 1, this is approximately equal to 1 plus or minus n times that x. Now, if we assume that d is much, much less than r sub e, then in fact, in this term, d over r sub e is very, very small. So we could apply the binomial expansion to this term. So if I look at this term, what's going to be considered n? Well, n is going to be negative 2, and x is d over r sub e. So let's rewrite it. 1 minus d over r sub e to the negative 2 is approximately equal to 1, and then we're going to pick the minus, and there's a negative 2 for n, then d over r sub e is our x, so that is equal to 1 plus 2d over r sub e. So we've simplified that term. It was difficult to deal with it before because it's squared, it's in the denominator. Now you've got a term over here that isn't squared, so this is one way of solving this problem is by applying the binomial expansion, making this term look a little nicer, approximating this term. And then we're going to I'm going to take this and plug it back in to the original expression. So what you have is mass of the sun over orbital radius squared times 1 plus 2d over r sub e minus mass of the Earth over d squared, and that's equal to the mass of the sun over r sub e squared times 1 minus d over r sub e. So now, if we go ahead and simplify, so go ahead and just multiply everything out, we get mass of the sun over r sub e squared plus 2d mass of the sun over r sub e cubed minus the mass of the Earth over d squared. And that's equal to the mass of the sun over r sub e squared minus the mass of the sun times d over r sub e cubed. So let's see, what can we combine? It looks like on both sides of this equation, we have the mass of the sun over r sub e squared, so that goes away. We have two terms that look alike. We'll combine them, 3d times the mass of the sun over r sub e cubed minus the mass of the Earth over d squared. That's equal to 0. So now those two terms, we set them equal and solve for what we're looking for originally, which is d. So we have 3d times the mass of the sun over r sub e cubed equals the mass of the Earth over d squared. So let's see. If we combine d squareds, we're going to get d cubed. And that's going to be equal to r sub e cubed times the mass of the Earth. Now we divide by 3, divide by the mass of the sun, and then we've combined all the terms. Let's take the cube root of both sides. So cube root of both sides. And what we're going to get is d is equal to, well, cube root of r sub e cubed is just r sub e. And all of that times the cube root of mass of the Earth divided by 3 times the mass of the sun. So if we plug all of that in, now you've got to be careful that this radius here is not the radius of the Earth, but it's the orbital radius of the Earth. So the orbital radius of the Earth is 150 times 10 to the 9 meters. Now, plug in the mass of the Earth, 5.97 times 10 to the 24th kilograms. Divide that by 3 times the mass of the sun, 1.99 times 10 to the 30 kilograms. And if you do the math, you get that that distance is 1.5 times 10 to the 9 meters. Now, we applied the binomial expansion to this. If indeed we look at the ratio of d to r sub e, it's equal to 0.01. So those two numbers compared, d is 1% the orbital radius of the Earth. So the binomial approximation is indeed applicable here. So it was a fair thing to do because, yes, d is pretty small compared to the orbital radius of the Earth.